Hello everyone and welcome to our second Tech Talk, where we take a closer look at the technology of our HF high-power transmitter. With me once again is Mr. Robert Träger, who is a senior system architect and designed our HF high-power transmitter. He is the expert when it comes to HF communications. In the last few months, we have talked a lot about the new high-performance HF technology, HF Wideband. By expanding the bandwidth used from the traditional 3 kHz to up to 48 kHz, the transmitted data rate can be significantly increased. An increase of up to 20 times can also be expected under real channel conditions. However, bandwidth is not the only variable limiting HF transmission performance. For this reason, we would like to take a closer look at the data link performance today. Robert, the HF channel is known as difficult. Can you say something about the data link performance?
Sure. Data link performance, of course, depends on current channel properties and propagation conditions of the radio link. An error detection mechanism prevents the protocol from delivering erroneous data to the connected network. And further error corrections techniques like ARQ, so automatic repeat request, secured data are implemented. As you already know, in addition to factors which are commonly known like the sun, the time of the year, the time of the day, the noise conditions, the antennas and the antenna sites, the HF channel is very slow and has to be used as efficiently as possible. The most significant problem is the turnaround time, that is the time taken to change direction of the data flow. The turnaround time is caused by multiple factors, so the HF modem turnaround time, the interleaver completion time, delays caused by the ComSec, that's the encryption and decryption of the data, the switching time from send to receive and vice versa of the radio, and finally the latency time over the skywave path. In total, we are talking about a turnaround time of at least a few seconds and sometimes as much as 30 seconds. This, of course, has a significant impact on the applications.
Understood. In addition to channel conditions, there are other circumstances that limit the performance of the data link. One example is the overhead in the data stream that is absolutely necessary to ensure error-free communication. Another example is the character of a half-duplex transmission that requires a reversal of transmission direction. Robert, are there any other additional aspects which need to be considered?
It is extremely important that applications use the HF link as efficient as possible, as the channel bandwidth is limited. There are several aspects that need to be considered. The compression of data, which kind of protocol and header overhead should be used, if data may be grouped in order to minimize the effect of turnaround time, and finally, the avoidance of repeat transmissions and to repeat them exclusively if data is lost.
I see. Nowadays, TCP/IP is the preferred protocol used by most modern applications. Are there mechanisms which allow to map IP onto an HF radio?
Yes, of course. IP can be mapped onto HF radio in a number of ways. There are two standardized mechanisms, STANAG 5066 and STANAG 4538. However, while there is already a draft for the connection of HF wideband to IP-based applications for the STANAG 5066, the STANAG 4538 is still limited to the classic narrowband HF transmission.
All right, thank you. Despite the introduction of high-performance HF wideband technology, data transmission in the HF band remains a challenge. Thanks to standardization, modern IP-based applications can also use the HF channel for transmission. The STANAG 5066 guarantees interoperability between manufacturers and is therefore certainly the preferred solution in NATO. The STANAG 4538 standard, on the other hand, is not consistently standardized, but simplifies the complete system architecture of an ICS, Integrated Communication System, significantly. It is therefore used more in isolated solutions, typically for non-NATO customers. Thank you very much once again, Robert, for your time and your expertise. I am looking forward to see you in our next Tech Talk. Thank you for watching and stay tuned.